In the 70s, they demonstrated the conversion of electricity into microwaves at over 90%. And then with the tight beaming, you have no more than about 1% loss in the transmission process. And then the conversion from electricity back into microwaves of 85%. Now that's in the last 10 years, that overall conversion efficiency, microwaves back into electricity, has exceeded 90%. The Japanese have a target of about 90% conversion efficiency from electricity to microwaves back to electricity of about 90%. And so that's very competitive when you send power over long distances. Electricity, high tension lines lose 5 to 10% depending on distance, whereas with the microwave, it's essentially independent of distance. So you don't send huge amounts of electric power across the country because you lose so much power once you get up to 1,000 or 2,000 miles or 1,000 miles through even DC power lines. Here, the distance doesn't really make any difference. In the system that we're talking about, you have focused beams, and so there is no spreading. They can actually be convergent. And basically, your loss is stray power that goes outside of the beam, and that will exist in any system, but it can be driven to an arbitrarily low level, depending on how you design, how large the transmitters are. And so it's just an economic trade-off as to how small that stray power will be. If you're providing all of your power from the United States, which you could, then it's as secure as we want to make it here in the U.S. These are very large distributed systems, the transmitters, and you could physically knock out 20% of a given facility, but it's highly redundant, and it would still generate or transmit 80% of its energy. As far as the satellites are concerned, just thinking along the flow of power, there are very few countries in the world that have the capability to challenge a large structure in space. They've got to fire at it. If they have an economic interest in making sure it's providing them energy, what would be their incentive to do so? You will know who tries to do damage to it, so it becomes like it's a much more favorable situation than, say, you're Saudi Arabia and you're sending a super tanker past Somalia or the Horn of Africa. No pirates are going to get up and interfere with a beam as it goes through space. The security on the receiver end, the people in the nation that are receiving the power, it's hard to see how they would have an incentive to want to interfere with their ability to receive power. And so part of it is the physical advantages. You're just not going through territories that want to cut you off. There is nobody, only the people on the space station are above 100 kilometers altitude, so who else is going to bother you? And it's a totally different physical situation than if you're going across political and natural barriers on the surface of the Earth. It just changes the nature of the game. Well, you load natural gas onto a tanker, and then 4 months later it shows up in the country that's going to use the electricity. You have no idea what the conditions are in that country. If you're sending to Japan, it's much more valuable now than it was before the nuclear meltdowns in Fukushima. So you can control where the energy is going to on a second-by-second basis, And you can determine in a non-destructive way to provide excess power to people who are paying the most at that time. So in that sense, it's similar to power management in a large utility in the United States. You can sell power at 3 a.m. at a lower cost than you would, say, in Houston when the air conditioners are running in the late afternoon at very high efficiency, or in Los Angeles during a time in which you need a lot of power. Another difference, and this is a very deep subject, another difference is that if you can supply power from many different regions to a given place on Earth, then they can all also compete to provide that power in a competitive manner back on Earth. So from the user standpoint, you've got more choice of suppliers. And so that should introduce some efficiencies into the system. This can be a system that on a world basis can really optimize the cost of power, both the suppliers finding the best market and the buyers finding the best suppliers. Well, the profit is specific to the company and to the shareholders that have an interest in it, but it's also related to how much total energy you supply. The more total energy you supply, the higher your profits could be. And then there are competing aspects of it. We clearly have to do more to control our CO2 emissions and waste products damage to the environment. And I think there might be a premium to electric power supplied this way because I believe that it provides a cleaner power with less emissions. And so society at large right now is trying to find some way to provide benefit to nations that reduce their carbon CO2 production. And this would be a way to do that. It could be done. Norway could be supplied with power from Texas, in which Texas buries the waste and supplies absolutely clean power as needed in Norway at a scale that Norway wouldn't be able to provide on its own, with its own resources. So you could extend that to Japan. Russia could become a supplier of clean power to any country in Europe without having to worry about disruptions in between Europe and Russia. It is a step in that direction, in that a transmitter that is transmitting non-renewable energy or power from coal or oil or natural gas can accept electricity from anything. And so it could say a transmitter in Saudi could accept electricity from natural gas, but it could also accept electricity from arrays of solar arrays in deserts in Saudi Arabia. And it makes the transmitter no difference whether it's natural gas produced or solar. And that solar could be supplied not just to Western Europe, but I don't know why, but to Australia, or it could be supplied to San Francisco when San Francisco is covered in clouds. And so this is a way that the microwave power transmission system is a way to let any energy producer provide its product to almost anywhere on Earth that is a significant power supplier, and decouples the characteristics of that power supply from where it's located. If that seller had many more buyers, it is in a more secure position. If the buyer had many more sellers, it's in a better position. So this system opens on a second-by-second basis the possibility of new transactions. And the whole purpose of power, electric power, is to produce wealth. And the steadier that supply of wealth, that supply of electric power can be, the steadier will be the production of new wealth. And in a high productive environment, $1's worth or €1's worth of electric power can produce $10 or $20 of output. And so what you really want is a way to enable more output, more total gain to be produced. And this will expedite that. So Switzerland is a very rich country by any reasonable standard. They could be richer if they had more supplies of electricity that had no environmental impact. They're a very hydro-intense country in terms of they've tapped out decades ago, their ability to get electricity from hydro. They've got nuclear, but they've got second thoughts about using nuclear. They need a supply of electricity which can grow and not produce environmental consequences in their valleys due to pollution and all. This would be a way to do that. They could bring in beams of microwave photons, produce electricity that will have no environmental downside to their fairly restricted developed areas. China is the example now. The United States was the example from after the Depression through World War II up to actually up into the 1990s. As long as our electricity supply was growing and becoming more efficient and providing more electricity to the entire country, the U.S. economy kept growing. We're now to the point, though, where it gets more and more expensive to provide the next increment of power, and our economy has slowed down. I think the whole problem of the U.S. lack of economic growth on a per capita basis is due to the fact that our electricity has not become less expensive and more pervasive and more dependable. China, on the other hand, is coming into the game about 80 years later, and they really started electrifying after the people emerged from the economic downturn, the failed policies in the 70s and the 80s. And their first emphasis was on providing electricity to the country, and they're still doing that. That's growing exponentially. And the more electricity they bring in, the richer they get. In about 20 years, they've gone from the order of $800 per capita economic output to over $4,000 in 20 years. I mean, it's just an absolutely remarkable achievement. We're up around 40,000 per capita, so they've still got a lot of growing to do. But it'll all be directly related to how much electricity they bring in. Now, their problem is that they're going to pay more and more for coal from Australia, eventually even from the United States, transported by ships. Other products from Brazil and similar countries. They would be much better off if they had a source of electricity that just appeared with no environmental downside to their economies. And one of the ways to do that is to bring that in from regions that are rich in these resources that can confine the waste products to near the production area and supply them with reasonably cost pure electricity. The whole world would be better off for that. Now we're in a transition area. There's enough coal, natural gas, and oil to provide economic growth, even worldwide, for many decades. But it's not going to decrease significantly in cost over that period because you've got to mine so much material and handle it with more and more constraints on how you handle it. You've got to put much more of the energy you produce into ameliorating the bad conditions the waste products and the expansion of the system provide that level of power. So what we're in is a transition era. And eventually what we have to do, and the sooner we do it the better, we've got to directly tap the sun rather than indirectly tap the sun, which is what you do with fossil fuels. And as we do that with bases on the moon, which accept the solar power and change it into electricity and then beam it down as microwaves to Earth, then you cut out all of the middle plankton, all of the middle ancient trees, and you go directly to, almost directly to the source. And then that enables you to have unlimited growth on Earth, and we start growing past the limits of Earth.